Here is another one in answers I did not find. Another question you might have asked yourself or someone else and never got the correct answer. So this one is about mathematics. If you studied the probability or introduction to probability, then you may have heard or read the term continuity of the probability function. So whenever continuity is involved, two topologies are involved, one in the domain, one in the codomain. So what does the probability function has to do with two topologies? They were not mentioned anywhere that I saw or heard or asked, but I discovered the answer myself. I thought about it, and no one whom I talked about knew. People who know more mathematics than I do, supposed to know more, they do know more, do not know what I figured myself. So the probability function is between the probability space, which is a measurable space, with a probability function, which is a special case of a measure. A measurable space is a pair of the underlying set and the sigma algebra on that set. The sigma algebra is a subset of the power set of the set, which is the set of all subsets, and the sigma algebra is a subset of it, which denotes which sets have a measure. The measure, the probability function, it decides the probability of each measurable set, but the sigma algebra decides which sets are supposed to have a measure. So the probability function is its domain is the sigma algebra, and its codomain is the R plus, the non-negative real numbers, and more precisely the closed interval 0, 1, 0,1. So the topology on the codomain is probably obvious for you now. It is the standard topology on 0, 1, which means the topology inherited, the subset topology of the real line, the usual one, the order topology, the metric topology, same topology in this case on the real line. Now the harder part, the unknown part, is the topology on the the domain, the sigma algebra. This one is the topology, and this is where my video is innovative. This is where what you will not find somewhere else. The topology on the domain in this case is the topology generated by open intervals on the subsets considered as a preorder by inclusion. So the inclusion between sets, this is a preorder on the set of all subsets, and in particular on the sigma algebra, which is a subset of the set of all subsets. And therefore you have open intervals. An open interval between two subsets A and B are all the sets that A is included in them, and that are also included in B. So between A and B, all the subsets S which include A and are included within B. This is an open interval A, B. So you have this type of subsets of the power set, and you can take the topology generated by this type of subsets, which one way to think about it is the intersection of all topologies in which every such open interval A, B is a member of the topology, is an open set. So the intersection of all such topologies can be called, and this is non-standard because I do not go by a certain book now, but it is the same as order topology, what I just did, except that this is not an order, this is a pre-order, but it is still a topology generated by open subsets. The same way it goes with order topology. It is a topology generated by open intervals. So here you got the topology on the domain. I already said that the more obvious part about the topology on the codomain. Now we have a pair of topologies, and now you can think about what the continuity of a function between them means. So this is it for now.